In this video, I will read through the Chapter 3 homework review that covers sections 3.1 to 3.5. I'll read the questions, I'll describe the graphs, and then I'll read the possible answers. If you want to use this as a self-guided review, you can stop after each question and then resume. I will give you the answers after a brief pause. I believe there are 24 questions on this review. Question number 1, find the value of the derivative, if it exists, of the function f of x equals, this is a fraction, the numerator is x squared, the denominator is x squared plus 49. At the extreme value point 0, 0, so the coordinates of the point are 0, 0. You do have a graph. The x-axis goes from -8 to +8. The y-axis goes from -1 to 2. The graph is similar to a parabola. It is above the x-axis. It only touches the x-axis at one point at 0, 0. It is a smooth and continuous function. Answer A, 1/8. Answer B, -1/8. Answer C, -1. Answer D, 0. Answer E, 1. If you want to pause the video and think about it. The correct answer is D. This came from Chapter 3, Section 1. Number 2, find the value of the derivative, if it exists, of f of x equals, in parentheses, x minus 2, to the power 4/5. So, open parenthesis, x minus 2, close parenthesis, and then the power is 4 divided by 5. There is a graph. The x-axis goes from -1 to 5. The y-axis goes from -2 to 2. The function is actually above the x-axis. It touches at the coordinate 2, 0. This is a sharp point. There is a closed dot, but it is a sharp point. It is similar to an absolute value graph. Answer A, f prime of 2 is undefined. Answer B, f prime of 2 equals, in parentheses, -4, and then to the 4/5 power. C, f prime of 2 equals 0. D, f prime of 2 equals 4/5 times, in parentheses, is a 2, and then it is to the -1/5 power. E, f prime of 2 equals, there's a 4 in parentheses, and it is to the 4/5 power. The correct answer is A, and that is from section 3.1. Question number 3, find any critical values of the function g of t equals t times the square root of, and then in parentheses underneath the radical is 2 minus t. T times the square root of 2 minus t is under the radical. It also gives you a condition that t is less than 2. Answer A, 0. Answer B, -2/3. Answer C, -4/3. Answer D, 2/3. Answer E, 4/3. The correct answer is E, and that is from section 3.1. B, Number 4. Locate the absolute extrema of the function g of x equals, this is a fraction, 4x plus 5 is in the numerator, 5 is in the denominator. So 4x plus 5 over 5. On the closed interval 0 to 5, there are brackets there. A bracket, 0, 5, and another bracket. A, absolute maximum, 5, 5. These are coordinates. Absolute minimum, 0, 0. B, absolute maximum, 5, 1. Absolute minimum, 0, 5. C, absolute maximum 5, 5, absolute minimum 0, 1. D, absolute maximum 5, 5, absolute minimum 1, 0. E, absolute maximum 0, 5, absolute minimum 1, 0. The correct answer is C, and this is from section 3.1. Number 5, locate the absolute extrema of the function f of x equals 3x squared plus 12x plus 3. On the closed interval, open bracket, -4, 4, close bracket. So the interval is -4 to 4. A, absolute max at the coordinate 499, 4, 99. No absolute minimum. B, no absolute max or min. C, no absolute max, absolute minimum at the coordinate 499, 4, 99. D, absolute maximum at 4, 99 coordinate, absolute minimum at the coordinate -2, -9. E, absolute max at the coordinate -2, -9. Absolute min at the coordinate 4, 99. Correct answer is D. That was from section 3.1. Number 6, locate the absolute extrema of the function f of x equals x cubed minus 12x on the closed interval 0, 4. So 0 to 4 in brackets. A, absolute max, the coordinate is 2, -16. Absolute min, the coordinate is 4, 16. B, no absolute max, absolute min at the coordinate 4, 16. C, absolute max at the at the coordinate 4, 16. Absolute min at the coordinate 2, -16. D, absolute max at the coordinate 4, 16. No absolute min. E, no absolute max or min. The correct answer is C, and that is from section 3.1. Number 7, identify the open intervals where the function f of x equals 6x squared minus 6x plus 4 is increasing or decreasing. A, decreasing on the interval -infinity to +infinity. B, increasing on the interval -infinity to +infinity. C, increasing on the interval -infinity to 1/2. Decreasing on the interval 1/2 to +infinity. D, decreasing on the interval -infinity to 0, increasing on the interval 0 to infinity. E, decreasing on the interval -infinity to 1/2, increasing on the interval 1/2 to infinity. The correct answer is E, and that is from section 3.3. Number 8, identify the open intervals on which the function y equals 9x minus 18 cosine x. The condition is 0 is less than x is less than 2 pi. And you want to know, where is this increasing or decreasing? A, increasing on the interval 7 pi over 6, 11 pi over 6. Decreasing on two intervals, 0, 7 pi over 6, and 11 pi over 6, 2 pi. B, increasing on two intervals, 0, 11 pi over 6, and 7 pi over 6, 2 pi. Decreasing on the interval 0 to 7 pi over 6. C, increasing on two intervals, 0, 7 pi over 6, and 11 pi over 6, 2 pi. Decreasing on the interval 7 pi over 6, 11 pi over 6. D, increasing on two intervals, 0, 7 pi over 6, and 5 pi over 6, 2 pi. Decreasing on the interval 7 pi over 6, 5 pi over 6. And E, increasing on two intervals, 7 pi over 6, 5 pi over 6, and 5 pi over 6, 2 pi. Decreasing on the interval 5 pi over 6, 11 pi over 6. The correct answer is C, and that is from section 3.3. Number 9, find the open intervals on which f of x equals -2x squared plus 12x plus 8 is increasing or decreasing. A, increasing on the interval -infinity to 6, decreasing on the interval 6 to infinity. B, increasing on the interval -infinity to 16, decreasing on the interval 16 to infinity. C, increasing on the interval -8 to -infinity, 32, decreasing on the interval 32, infinity. D, increasing on the interval -infinity, 24, decreasing on the interval 24, infinity. And E, increasing on the interval -infinity, 3, decreasing on the interval 3, infinity. The answer number 9 is E, and that is from section 3.3. Number 10, for the function f of x equals 4x cubed minus 48x squared plus 6. Find the critical numbers, part A. Find the critical numbers, if any. Part B, find the open intervals where the function is increasing or decreasing. And part C, apply the first derivative test to identify all relative extrema. A, for part A, there's three answers. A, x equals 0 and 2. Part B, increasing from negative infinity to 0, union 2 to infinity. Decreasing from 0 to 2. C, relative max f of 0 equals 6, relative min f of 2 equals negative 154. Answer B, part A, x equals 0, x equals 2. Part B, decreasing on the interval negative infinity to 0, union 2 to positive infinity. Increasing on the interval 0 to 2. C, relative min is f of 0 equals 6, relative max f of 2 equals negative 154. All right, answer choice C. Part A, x equals 0, x equals 2. Part B, increasing on the intervals negative infinity, comma 0, and 2, comma infinity. Decreasing on the interval 0, comma 2. Relative max, f of 0 equals 6, no relative min. Okay, part D, answer D. Part A, x equals 0, x equals 8. Part B, increasing on the interval negative infinity, comma 0, and union symbol, 8, comma infinity. Decreasing on the interval 0, comma 8. Part C of this answer, relative max, f of 0 equals 6, relative min, f of 8 equals negative 1018. Answer choice E. Part A, x equals 0, x equals 8. Part B, decreasing on the intervals negative infinity to 0 and 8 to infinity. Increasing on the interval 0 to 8. C, part C, relative minimum f of 0 equals 6, relative maximum f of 8 equals negative 1018. Correct answer to number 10 is D, that is from section 3.3. Number 11, determine the open intervals on which the graph of f of x equals 3x squared plus 7x minus 3 is concave downward or concave upward. Answer A, concave downward on the interval negative infinity to positive infinity. Answer B, concave upward on the interval negative infinity to 0, concave downward on the interval 0 to infinity. Answer C, concave upward on the interval negative infinity to 1, concave downward on the interval 1 to infinity. Answer D, concave upward negative infinity to positive infinity is the interval. Answer E, concave downward on the interval negative infinity to 0, concave upward on the interval 0 to infinity. The correct answer is D, and that is from section 3.4. Number 12, determine the open intervals on which the graph of y equals negative 6x cubed plus 8x squared plus 6x minus 5 is concave downward or concave upward. Answer A, concave downward from negative infinity to positive infinity. B, concave upward on the interval negative infinity to negative 4/9, concave downward on the interval negative 4/9 to infinity. C, concave upward on the interval negative infinity to 4/9, concave downward on the interval 4/9 to infinity. Answer D, concave downward on the interval negative infinity to negative 4/9, concave upward on the interval negative 4/9 to infinity. Answer E, concave downward on the interval negative infinity to 4/9, concave upward on the interval 4/9 to infinity. The correct answer for number 12 is C, and that is from section 3.4. Number 13, determine the open intervals on which the graph of the function f of x equals. We have a fraction, x squared is in the numerator, x squared plus 625 is in the denominator. You want to determine where it is concave upward or concave downward. All right, so these answers are mostly in fractions. I'll read them as one over the other. Answer A, concave upward on two intervals, negative infinity to negative 25 times square root of 3 over 3, and positive 25 times square root of 3 over 3, comma, infinity. So 25 square root of 3 over 3, comma, infinity. Concave downward on negative 25 square root of 3 over 3, So numerator is 25 square root of 3, denominator is 3 each time, comma, 25 square root of 3 over 3. So a positive 25 square root of 3 over 3. Part B, concave upward, negative, this is a fraction, 25 square root of 3 over 3, comma, 25 square root of 3 over 3. Concave downward on two intervals, negative infinity to negative 25 square root of 3 over 3, and 25 square root of 3 over 3, comma, infinity. C, concave upward from negative infinity to 0, concave downward from 0 to infinity. D, concave upward on the interval negative 625 over 3, comma, 625 over 3. Concave downward on two intervals, negative infinity to negative 625 over 3, and then the next interval, 625 over 3 to positive infinity. E, concave upward on two intervals, negative infinity to negative 625 over 3, and then 625 over 3, comma, infinity. Concave downward from negative 625 over 3, comma, positive 625 over 3. The answer to number 13 is B. That is from section 3.4. Number 14, find all the points of inflection of the graph of the function f of x equals 1/2 x to the 4th plus 2x cubed. Answer A is the coordinate negative 2, negative 8. Answer B is the coordinate 0, 0. Answer C has two coordinates, 0, 0 and negative 4, 0. Answer D has two coordinates, 0, 0 and negative 2, negative 8. Answer E, negative 2, negative 8. The correct answer is D, and that came from section 3.4. Number 15, find all the points of inflection and discuss the concavity of the function. F of x equals 4x cubed minus 5x squared plus 5x minus 7. Answer A, inflection point at x equals negative 5/12. Concave up on the interval negative infinity, comma, negative 5 over 12. Concave down on the interval negative 5 over 12, comma, infinity. Answer B, inflection point at x equals 5 over 24. Concave downward on the interval negative infinity, comma, 5 over 24. Concave upward on the interval 5 over 24, comma, infinity. Answer C, inflection point at x equals 5/12. Concave downward on the interval negative infinity, comma, 5 over 12. Concave upward on the interval 5 over 12, comma, infinity. D, inflection point at x equals negative 5/12. Concave downward on the interval negative infinity to negative 5/12. Concave upward on the interval negative 5/12, comma, infinity. E, inflection point at 5/12. Concave upward on the interval negative 8, comma, 5/12. Concave downward on the interval 5/12, comma, infinity. The answer number 15 is E, and that is from section 3.4. 16, find all the points of inflection and discuss the concavity of the function f of x equals negative 8x minus 2 cosine x on the interval 0 to 2 pi. There are brackets around that. A, concave down on the interval 0 to 2 pi, no points of inflection. B, concave downward on the interval pi over 2, comma, 3 pi over 2. Concave upward on two intervals. The first one is 0, comma, pi over 2. The second one is 3 pi over 2, comma, 2 pi. Inflection points at x equals pi over 2 and x equals 3 pi over 2. Answer C, concave upward on the interval pi over 2, comma, 3 pi over 2. Concave downward on two intervals, 0, comma, pi over 2 and 3 pi over 2, comma, 2 pi. Inflection points at x equals pi over 2 and x equals 3 pi over 2. D, concave up on the interval 0 to 2 pi with no inflection points, and E is none of the above. The answer is 16 is B, and that came from chapter 3, section 4. 17, find the limit of. The limit as x approaches infinity, and then in parentheses your function is 5 plus 3 over x squared. So limit as x approaches infinity, open parenthesis, 5 plus a fraction, 3 in the numerator, x squared in the denominator, close parenthesis. Answer A is infinity, answer B is 3, answer C is negative infinity, answer D is negative 3, and answer E is 5. Number 17, the answer is E, and that is from section 3.5. Number 18, find the limit of. It says limit as x approaches infinity. This is a fraction. The numerator is 3x plus 2. The denominator is negative 6x minus 6. Answer A is 1, B is 0, C is negative 1/3, D is negative 1/2, E is does not exist. The answer to 18 is D, and from this is from section 3.5. Number 19, find the limit. Limit as x approaches infinity. This is a fraction. The numerator is negative 8x plus 2. The denominator is negative 5x squared plus 4. Answer A is 1/2, B is 1, C is 0, D is infinity, and E is 8/5. Correct answer in 19 is C. That is from section 3.5. Number 20, find the limit. Limit as x approaches infinity. This is a fraction. In the numerator is negative 6x. In the denominator is a radical. Underneath the radical, 64x squared minus 5. So on the bottom, square root of 64x squared minus 5. Answer A is negative 3 over 32. It's a fraction. Answer B, negative 3/4. Answer C is 1. D is negative 6. E is negative infinity. Correct answer number 20 is B, and that is from section 3.5. The remainder of these questions are from 3.5. Number 21, find the limit. Limit as x approaches infinity. We do have a fraction. In the numerator is 7x plus 6. In the denominator is a radical. Everything is underneath the radical, so it is square root of 64x squared plus 2x. So 7x plus 6 on top, on the bottom, square root of 64x squared plus 2x. Answer A, 7/8. Answer B, 7 over 64. Answer C is 1. D is 7. E is infinity. The answer number 21 is A. Number 22. The graph shows the temperature T in degrees Fahrenheit of the molten glass T seconds after it is removed from a kiln. So our y-axis is a capital T for temperature. The x-axis is the small t for seconds. Okay, the graph has a point at the coordinate 0, 1700. It begins there, and it decreases but stays above the x-axis to infinity. There is an asymptote at y equals 72. So it says, find the limit t as t approaches infinity. A is 1,772 degrees. B is 72 degrees. C is 1,700 degrees. 1700. D is 89 degrees. E is 1,628 degrees. The correct answer is B, 72 degrees. Number 23, a model for the average typing speed S, words per minute, of a typing student after T weeks of lessons is given by S equals, this is a fraction, in the numerator 81t squared, in the denominator 12 plus t squared. The condition is t must be greater than 0. Find the limit S as t approaches infinity. There is no graph for this one. Answer A, 96 words per minute. Answer B, 12 words per minute. C, 56 words per minute. D, 162 words per minute. E, 81 words per minute. Correct answer is E. Last question, number 24. A heat probe is attached to the heat exchanger of a heating element. The temperature T, capital T in degrees Celsius, is recorded T seconds, that's a lowercase t, after the furnace is started. A model for the data recorded the first 2 minutes is given by, there is no graph, capital T equals, this is a fraction, in the numerator 1,351 plus 78t, that's lowercase t. In the denominator 54 plus t, that is lowercase t. Find the limit as lowercase t approaches infinity of the whole function capital T. A is 1,429 degrees, B is 1,351 degrees, C is 54 degrees, D is 78 degrees, and E is 25 degrees. The correct answer is D. If you have any questions on these and you need any assistance, please let me know.